Welcome to today's online academy. In this online academy, we will talk about the structure of the connector data, and we will also create a cam fitting from scratch, so that after this online academy, you will understand how all the elements are working together, like what are connectors for, what are connector sets doing, what is a connection situation, and what are part numbers. And this is the thing that we will start with. So regarding connectors, it's quite important to know that there are certain part numbers. For example, for corner connections, we only have 2 part numbers, and there we have part number 0 and part number 1. And part number 0 in a corner connection will always be the onset part. Like here for this bottom article, it's the top shelf, and for the top article, it's the side panel. And part number 1 is always the inside part. So in this case, here, this bottom shelf and the side panel here. And these part numbers are responsible for the connectors to have the correct orientation, and they are also responsible for the machinings that they are inherited into the correct parts. For example, this connector set consists of 2 connectors, and this screw-in dowel wants to inherit 2 machinings, and it knows that it has to be oriented on part number 0, and that it has actually 2 machinings, 1 small drilling, which will be inherited into part number 0, and a bigger drilling that is inherited into part number 1. And this cam fitting here is only inheriting 1 machining into part number 1. So this is what the part numbers are actually for. And this is quite important to know before we start with the structure of the connector data. So let's begin and let's see what elements do we actually need to get a result like this. First of all, in the element manager, we have connectors. This is basically the first item or the first element that we need. When we take a look at these connectors here, we see that we have several settings that we can do. First of all, we have default settings, which are basically more or less to handle the visualization. So we can actually say that this connector, for example, should be visualized from VISO mode 1, so that it is independent from the VISO manager itself, which is useful for some connectors like handles that we want to see all the time, but we maybe want to hide all the other connectors in our cabinet. So in this case, we could say, I want to show this connector from mode 1 or from one of the other modes. Then we have commercial informations, which is quite self-explaining. So we can add a preview picture here, which will be shown here on the right side in the element manager. And we can add all the other commercial informations and also the prices and the weight and a markup factor for the price. But what is more important when we talk about connectors is actually that we have these characteristics, which we call constructive characteristics for connectors. So when we set up the cam fitting, I will explain you in detail what these characteristics are for. And we will also see that every element that we are using here in this online academy will have some characteristics. And it's quite important to know and to distinguish between these different characteristics. So I will try to explain this in a very detailed way. But the most important part regarding connectors are the machining groups here. So each connector must have at least one group, And here in this group we can see we can assign a part number, we can assign a work group for the machinings, and we can assign a drawing. So basically we can say from the connectors we get the machinings and the drawing of the connector itself, and then we have to know that IMOS doesn't insert connectors in our construction. IMOS always inserts connector sets. So the next item that we would need are connector sets. And in these connector sets, we have different folders, but these folders are not simply folders. These folders are so-called connection types. So in each connection type, we have different connector sets. And here, for example, we can assign default settings again. Basically, we only see the usage frequency, which is the amount of selections that we did in the connection scan. We can put this back on 0, but we cannot just put the number higher. Then we have to assign our different connectors here. So as the name already says, connector sets, they consists of several connectors that we can assign here, and we always need a connector set, even if the connector set only consists of one connector, like for wooden dowels, for example. Then we also need a connector set that has assigned only one connector. And for cam fittings, we have these two connectors assigned here. And as we see, again, we have characteristics, or here they are called attributes. So these attributes are basically catalog characteristics. And here we define what constructive settings must be fulfilled, or what constructive requirements must be fulfilled that we can actually use this connector set. Because we cannot use it from any thickness, the panels must have a certain thickness for this connector set that we can use this. And also for cam fittings, the inner body angle must be, for this one, for example, 90 degrees. Otherwise, the connection scan would have to choose a different connector set. And the last element that we need here, we find it here under construction principle, connections, and then connection situations. So this connection situation consists of another connection. A connection situation can have multiple connections, like for example, cams and dowels. There we have two connections, and each connection is responsible for inserting the connector set, or also for choosing the connector set. Depending on how we want to work, we can whether use the connection scan, which scans our article and checks the catalog characteristics, or we can also choose from a direct selection where we actually have to assign one connector set. But I will show this in detail now when we set up the cam fitting itself. So for the cam fitting, I've looked up something from the Häfele website again. So here we have these two single items. So this one is just the cam, and this one is the screw-in dowel that I want to use and that I want to combine. And now I have downloaded the drawings already, which we need to set up this connector set. And I will just open these drawings. I didn't change them so far because I also want to show you what's important regarding these connector sets or these drawings for the connectors. And as we can see, I have a screw-in dowel here, which is in this case a block reference. we don't really want to use block references in our DWGs. So I will start exploding this block reference, and at the end I have a 3D solid, which is better because when IMOS inserts this drawing, it will insert it as a block. And when the drawing is already a block, we have a block in a block. And then it can happen that in some cases it can happen that this block doesn't even show. So it's better to not have any blocks in the connector drawings. So usually Hairfiller also hides a logo here on the insertion point, which is another block. I will just delete this logo, and then we can have a look at the orientation and the insertion point of the drawing. The insertion point is the 0 coordinate in this drawing, and we see that it is located here in the center of our screw-in dowel and at the position where it is actually referenced to part number 0. So this is okay. We can keep it like this. And of course we can check the colors, but this one is already fine. Hairfiller usually has some pretty good drawings always. So we will keep this like it is. We will just purge the drawing, purge everything out, and then we can save this drawing. Of course, we have to save it. Of course, we have to save this drawing in our library folder, in the connector DWG folder. This is where all our connector drawings are located. And we should maybe also change the name so that it is easier to find this drawing. So I usually keep the article number, and then I will call it Online Academy, underline Hairfiller, underline then the article number, and I save it. And then we take a look at the other drawing, which is the cam. And here we see that the insertion point is on the top of the cam, so actually on the surface of part number 1, and also in the center of the cam fitting. This is another block reference. I will just explode this again, and I will check if there's the Hairfiller logo, which I will delete. Okay, now this looks good, and the insertion point is also already good. It can be that the orientation is not the best one, but we will figure that out later when we insert this fitting. So I just changed the name again to Online Academy Hairfiller, and then the article number again. And what I also need, what I don't necessarily need, but what I want to have are preview pictures. So I will take this picture here and save it in my info folder. In the info folder, all preview pictures are located. Inside of the info folder, we have different folders like dir for directories that is actually shown in the Explorer, or bitmaps for all our connectors, or Angulo for all of our articles in the article center. So I will save this picture here in the bitmaps folder. Save it as Online Academy Hairfiller and the article number, and for the screw-in dowel I will do the same. Okay, and then we are good to go. So now we start setting up the connectors itself, and therefore we switch to the element manager and to the connectors. So first thing we do is create a folder for Online Academy and for CAM. And then I take the standard connector and I just rename it Online Academy and CAM. So save it and move it. And then we start setting up the commercial information. So this is the position where I can actually assign my preview picture. You see that it already jumps into the bitmaps folder. So I just take this preview picture here and I get a nice preview of my connector. And then I will just type in the article ID. Then I just copy the description from the Hairfiller homepage and I assign the supplier here. Okay, so this doesn't need any explanation, but what is more important are the characteristics that I will talk about later. First of all, I will set up the group, and we already learned that our cam fitting has to be assigned to part number 1. Just to repeat this, part number 1 is always the inset part, so this is the part from which this cam fitting should be referenced. And we also want to understand how are the connectors actually referenced to the different parts, or how do they actually get their insertion point. So I assign part number 1 here, which also means that the workgroup that I will assign here is also inherited into part number 1. So for the workgroup, I have to create a new one. So this will be a drilling. This cam fitting needs a drilling depth of 14 and it has a diameter of 9. No. Let's measure that. So my drilling here will be 15 by 14. So I have a machining of the type hole, and I leave the insertion point and the orientation for this drilling on 0. That means that this hole will actually be referenced on the insertion point of my drawing. So I save this and I apply this, and then I assign the drawing name. This one. And I also leave the insertion point on 0 and the orientation as well. the better the insertion point and the orientation is in my connector drawing, the less I have to set up here. Basically, I could change the insertion point here as well. So actually it doesn't matter. It doesn't really matter where the insertion point is, because I could make all the changes in the connector itself as well. But the better the insertion point and the orientation is, the less I have to set up here. So if I have the perfect orientation and the perfect insertion point, all the values here can be on 0. So this fitting is ready for now. Now I will set up the screw-in dowel. And therefore I take the other preview picture. So this one has the article number 262.28928. Okay, and here I also don't insert any characteristics yet, because it's easier to explain them later. So I will set up the group. So we know that this connector must be assigned to part number 0, and we want to inherit a small drilling into part number 0. So we actually have a length here which is 11 millimeters. So this is my drilling depth, and I need a diameter of 5 for this. But I will put the depth on 12. So I have the depth of 12 and a diameter of 5. And I also need a second drilling, which is the length B here. And this is 34 millimeters. So I create a second drilling. So this one must have a diameter of 7 and a length of 34. Why do I need to have 2 work groups? I could also assign multiple drillings here in this one work group. The reason for that is simple. This drilling is inherited into part number 0, and the other one is inherited into part number 1. That means I need a second group. So, but first of all, I will assign this join, and then I create a second group that is responsible for part number 1. And this group will get the long drilling here, the 34 drilling, and the number of groups that one connector needs is usually depending on the different parts that this connector wants to inherit machinings to. So in this case, I need 2 sub-assemblies or 2 groups, and it is enough if one group has the drawing. So this group doesn't need the drawing again, then I would get 2 drawings or 2 screw-in dowel drawings in my construction later, and I don't want that. So now I have my 2 connectors, and now I will create a connector set here. Therefore, I just take any connector set as a template, and I just call this Online Academy Cam. I move this into my folder, and then I start setting this up. So first of all, I assign both of my connectors. The first one is my cam fitting, and the second one is my screw-in dowel. And then we need to take care of the attributes. So these attributes are to distinguish between certain connector sets in the same connection type. Usually you don't have to change this. I will keep this for now. And then we have a thickness of the inset part. The inset part is part number 1. So basically, here I have a depth of 13.5. So the inset part must have a minimum thickness, I would say at least of 16. So here I start, it's already the value here, 16 to 18. Basically, I could also go higher, 16 to 60, for example, if I want to use it for a thickness of 60 as well. Then I have my inner body angle. This must be 90 degrees. Otherwise, I would have to use a different cam fitting that can actually bend. And the thickness of the onset part, that's actually this drilling here. We still remember that this drilling was 12. So I would say the thickness of the onset part must at least be 14. That's maybe already a little bit close, but I think it will be okay. 14 to 30. Yeah, I can also go up to 60 or to whatever. And to make sure that later I will only get my connector set, I use an additional filter here that is Online Academy as well. Okay, so I have my connectors, I have my connector set, and now I will choose my connection situation, or actually I will create my own connection situation here. Online Academy Cam. So every connection situation at least has one connection. And I have to set up the way this connection should work. There are 2 ways to insert connector sets with a connection. I already said I could whether use a direct selection. In this case, when I use a direct selection, I can do my selection here. So basically, I just choose a connector set and assign it to this connection. And then in this case, all these attributes of my connector set doesn't play any role. So because then there is no proof, or there won't be a connection scan that checks if this connector set actually fits to my construction. Because I made a direct selection and I said I want to use this connector set every time, so IMOS will insert this connector set no matter what happens, even if it doesn't fit. For some connector sets it's useful, obviously, but for other ones we want to have our tool, the connection scan, that actually scans the article and checks all the attributes and compares them to the attributes of the connector sets, and then it can decide if this connector set is suitable for our construction or not. So for height adjusters or for handles, maybe you can do a direct selection, but in most cases I would recommend to use the connection scan. In case of using the connection scan, we cannot do a direct selection, of course, because in this case we can choose from all our connector sets. And in this case, we only have to assign the connection type. Maybe you still remember what the connection type was. So when I go back to the connector sets, I said that all the connector sets are located in different folders, but these folders are not simply folders. These folders are connection types. So basically now I tell my connection that it should look in the folder, or better to say in the connection type cam fittings, which is this here, the cam connection. So I apply this and now it already knows, okay, I should use the connection scan and I can only choose from this connection type. So this connection is not able to insert any handles or cup hinges or drawers or whatever. It can only choose from this folder. And the next setting I can do is a linear division. So here we can just insert a linear division, or we can insert a variable, or we can insert a descriptor. For connectors, we usually use descriptors in this case, but I don't want to talk about descriptors. In this online academy, I will just use a linear division, which is 1-to-1. And for corner connections, this is enough. For corner connections, we always have only one linear division. For surface connectors, we will have a second linear division. If you, for example, have a height adjuster that is assigned to the surface of a part, in this case, you would need a second linear division. But for corner connections, it's only this one. So I don't have to take care of the rest here. These are all settings that are only used for surface connectors. Okay, so let's save this and then we can check the attributes here. So the attributes are usually blank in the connection situation because these attributes, or let me explain you what happens already. So I told this connection it should use a connector set from this connection type. So as soon as I insert my article in my drawing, the connection scan will scan my article. It will check the attributes. So it will recognize that the onset part, for example, is 19 millimeters. The inside part is 19 millimeters as well. And my inner body angle is 90 degrees. And with these values, it jumps into this connection type and it checks what connector set actually fits into my construction. And then it will make a list of all the connector sets that would fit, and it would insert one of these. So basically I don't have to use these attributes, but these attributes are additional requirements that the connector set has to fulfill. Which means if I, for example, type in an additional filter, the connector set must also have this additional filter. otherwise it cannot be selected. So now I typed in this additional filter, and I only have one connector set in my whole database that has this one additional filter, so I will only be able to choose from this connector set. But still I can use the connection scan to check if this fitting is suitable for my construction. So I save this, and then I will apply this connection situation to my construction principles. I will just overwrite my construction principle here. Okay, I refresh my article, and now I should get my connector set. You see how it looks like. Not really correct. The orientation is still wrong, and we see where the connectors are actually referenced. So the screw-in dowel has the insertion point here at the blue square, which is on the inside of part number 0. And my cam fitting has the insertion point also at the same position, and that's also referenced to part number 0, or on the inside of part number 0 and on the inside of part number 1, which is basically not really correct. But first of all, let us change the orientation. The orientation for the screw-in dowel is already correct. The orientation for my cam fitting is not correct, so I go back into the drawing. Now I would have two options. I can whether change the orientation here in the drawing, or I could change the orientation in my connector. So I will change the orientation in my drawing, which means I have to rotate around the x-axis in this case. What are these lines here? I don't know. So I will rotate around the x-axis by 90 degrees, like this. Then I save my drawing again. And now it's important to know that you cannot simply refresh the article. You won't see a difference. In this case, we would have to refresh the blocks, and there's a function for this. In this case, IMOS reloads all the blocks that are inserted into this drawing. So now you see that my orientation has changed. So the orientation is correct already. Now I just have to move these connectors. And there's also a way to identify if the machinings are inherited into the correct parts. So you see that my small drilling here is inherited into part number 0. And in part number 1, we should get the other two machinings that still have the wrong orientation as well. So I will need to change this. So first of all, let's have a look how we can move these connectors. Basically, I would have to, or I have two options to move these connectors. One option would be just to change the insertion point of my drawing and of my work group. Like this, I can move it. For example, I could change the insertion point X to 34. Refresh my article, and then then the cam fitting moves by 34 millimeters in its X direction. Of course, I chose the wrong axis now, but that doesn't even matter because I don't want to change the insertion point here. I will keep it on 0. Now we come to the constructive characteristics of connectors. So these constructive characteristics are actually useful because they are responsible for the connectors to have a kind of intelligence so that they can communicate with each other. First of all, I will assign a fitting type here, which is a corner connector in this case, and then I can assign one constructive characteristic, and there's one constructive characteristic for cams that is called dowel adjustment. So this characteristic actually tells the screw-in dowel where its position has to be regarding the thickness of part number 1. So I will just say this has to be on 9.5 millimeters. And then I refresh my article. Let's take a look from the front view. So I refresh my article and my screw-in dowel moves together with the machining. So my machining is a little bit too short, I guess. So I will have to, no, it will be okay because the other drilling will be at this position as well. So now the position of my screw-in dowel is correct already. And then I will assign another characteristic here on my screw-in dowel, because this screw-in dowel tells the cam fitting now that it has to have an offset. There is a characteristic called offset first cam connector, and this will set the cam fitting off from the inside edge of my part number 0 into the depth of the part. So this must be on 34. Save it, refresh the article, and now my cam fittings or my cam fitting jumps to this position here. So why should I do it like this with the characteristics? Why didn't I simply change the insertion point of the connector itself? Of course, I could have changed the insertion point here, but if I would have done this, I would have a fixed insertion point. And imagine I would combine this cam fitting with a different screw-in dowel that is, for example, much shorter. In this case, I would have to create a second cam fitting, which is just a duplicate of this one that only has a different insertion point. So you see that these constructive characteristics are responsible for the connectors to communicate under each other, so that the screw-in dowel tells the cam fitting where it has to be positioned, and the cam fitting tells the screw-in dowel where it has to be positioned in the thickness of the part. So I just can combine any cam fitting with any screw-in dowel, and they will always change their position according to the length of the different connectors. So let's see that we get the correct orientations for our machinings. So I guess I have to rotate the machining for the cam fitting around the x-axis. Let's try this out. Yeah, and now it's okay. So now I set up my cam fitting here, and this is basically the way how you can set up your own connectors and how you can influence the position and the orientation. And if I check the connection scan now, I will quickly explain what you can see here. So in the connection scan, you see that I only have one connector set to choose from, and the connection scan of course shows me all my connections. And if you mouse over the connection here, it shows you this small window with all the values that the connection scan scanned from the article. And you can always compare these values. Sometimes if you don't get the connector set that you like, or that you actually need to insert, you can just screenshot that and compare the values by yourself. So you switch to the connector set that you need. So you can also always check the characteristics by yourself. So you can take that screenshot and you just can compare. Is the stop type correct? Fitting group and fitting type, is this one correct? And the scanned values in between the range of the values that you typed in for your connector set. And then you can figure out why this connector set won't be found from the connection scan in case it doesn't find it. So yeah, that's the end of this online academy. I hope it helped you a little bit, and I would like to see you next time again. And yeah, have a nice weekend. Bye bye.